Welcome back to my channel. I'm Brian Kapicki, and today we're going to cover understanding the Hive Metastore, which is an integral part of Apache Spark and Databricks. It's also really critical to understanding a newer service available in Databricks called Unity Catalog. So let's jump in. So let's start off with just a simple description. What is a Hive Metastore? It's a catalog that stores data that describes data. And that's called metadata, new term for you, really good for interviews, right? So that's what a catalog is. The Metastore or metadata catalog, it stores information that describes your table. So it tells you what the table name is, what are the columns, what are the data types, all kinds of information we'll see later when we describe a table, but that's what it's all about. And we're going to see that this is not really a new concept, but on Apache Spark, it's applied in a little bit different way than, say, in SQL Server. The whole goal of the Hive Metastore, at least its origins, is to support the SQL structured query language. So kind of make Spark act like a SQL database. Another part of the Metastore is that it tells Spark where the data is. And I'm going to explain that there's actually two parts when we talk about a table. There's the physical storage that holds the data, but there's also the Metastore, the descriptive information about the data, and they're not in the same place. So when we talk about the Hive Metastore, another part of what it does, it points to the file location. It could be, like Azure Data Lake storage or blob storage or whatever you happen to be using. And the ultimate purpose of the Hive Metastore is to allow your Spark clusters to treat data just like SQL tables. In other words, to give you that database management service functionality that you're so used to. And finally, I do want to point out that this is not new. The Hive Metastore actually goes back further than Spark. It goes back to the Hadoop MapReduce days, and this was a way that MapReduce could support SQL. So as I mentioned, a metadata store is also called a catalog. And let's take a look at something in a familiar scene. Like you've used this before, but maybe you never really thought about it like this. So let me step back and explain this in a very traditional SQL database way. Imagine we're using, I'm just going to use SQL Server, but it could really Oracle, anything else would work the same. You issue this nice little SQL statement, select data, blah, blah, blah from a table. And that's going to go out. And I use this image of SQL Server Management Studio, which shows you in particular the information underscore schema, which is where the SQL standard has said this is where metadata should be at least materialized to people to query. Now, originally SQL Server didn't support the information schema, but it is SQL standard now, so they make it visible through this. But the point of this is you can see in this metadata, right? This is the tables in SQL Server that store information about all the SQL objects, including tables and views and yada, yada, yada. For your query to work, the SQL engine is going to have to reach out and get the data from flat files, actually. At the end of the day, whether you're using Oracle or SQL Server or any other Postgres or whatever, you're going to be actually still getting to flat files under the covers, but it's hidden from you, right? The SQL databases require you to go through them, and then they figure out how to get to the data. So it's hidden from you, and you really can't go directly to it. But when you type in the SQL statement, it goes through this metadata catalog and then finds the file. And more importantly, it gets descriptive information about what is in the table. Like, where is the table? What does it look like? What are the data types, column names, and on and on. Now, once it gets that information, it has what it needs to send the results to your query back. So takes your query, is able to process them, and then send the results back to you. And you get this nice little table suitable for framing. Full circle, you've got everything you need, and it was using a metadata catalog, also often called the database catalog, and it's got a lot of metadata tables. So let's take a little look here at the Hive Metastore and see how it is similar to that. So imagine you've got this data lake here, right? You've got employee data and departments and jobs, but first thing to realize is this data pre-exists any relational database, and it doesn't inherently support SQL at all, right? It's just files that are sitting out there. They could be in any kind of format. They could be CSV or JSON or anything you want, XML. You got this data, and you still want to use this good old query. You want to use SQL against it. How are we going to do that? Well, and I mentioned here you can have different types of formats. So what you're going to have to do is go through a catalog, right? Just like in a relational database, And in this case, it has this catalog entry for the employees table, and it has the column names and everything. I didn't stick to the naming exactly the same, so you may find some differences here. But the main point is that when I do my query, it's going to go into the Hive catalog, symbolized by the little bumblebee there, go to the data lake and query the data. Now, what the catalog is doing in this case is, as I mentioned, the files pre-exist. So imagine employees is really a CSV file. Then what is stored in Hive is the name of the table, where it is physically stored, and then descriptors of what each column is in the CSV file and what the data type is. Not only do you get nice SQL support in your queries and working on Databricks when you use the Hive Metastore, but tools like Power BI also rely on it. It would be extremely awkward and difficult to go directly against all these different types of file formats in a data lake. So a much easier way to do it is to create catalog entries for the files, and then Power BI can just query those. Now I want to be very careful here because there is a difference that I need to emphasize. In the relational database world, the catalog is an integral part of the data. In fact, you must ingest the data so that it can make sure everything follows the schema definitions, the column types, everything is validated. And that's one of the reasons why it doesn't work really well for big data, because ingesting a trillion rows can be a very time-consuming process. You're not going to be doing that like every 5 minutes. It's going to take time. In the data lake world, you can see here, we just landed the files. We've got employees and departments, and these could be massive files. We are not going to ingest those files again just to get SQL support or to create catalog entries. Instead, we're going to create little descriptors, right, in our Metastore, and then we can query on top of it. We don't even have to change the formats. You can put a SQL descriptor and point to a CSV file, and it will let us now query. As long as it knows what the different columns are and that it is a CSV file and where it is, it can support querying, select, order by, and on and on. It'll also support JSON and text files and even Delta tables or Parquet and that kind of thing. So you can see where this is really powerful. And finally, it also can be key for tools like Jupyter Notebooks or Snowflake or even Python to be able to query the data. It can use the SQL and the Hive catalog to be able to navigate the data lake more easily. Now, there is a key thing I'm going to emphasize in a minute, which is this is all happening in a single workspace. So the Hive Metastore is singular to each workspace. What do you mean by that, Brian? I mean that there's a one-for-one correspondence between the Hive Metastore and a Databricks workspace. All right, so let's jump into a riveting demonstration here of how this is going to work. I'm going to start out by creating a database. If it doesn't exist, it says it'll create it. If it already exists, then it will just use it. So I'm going to run that in my cell here. And most of the statements I'm going to show you are SQL, but some are Python too, so we'll see that. When you want to stay in a certain database and you don't want to have to keep prefixing every table with the database name, like demo.table, a nice technique is just say use. Use changes the context so that everything after that is sitting in that database. It's a lot like change directory when you're in a folder structure. You say CD or whatever and get into a subfolder, and now you don't have to keep referencing the folder structure. It looks locally. And that's kind of what's happening here. So I'm going to say use demo, and then from that point forward, it assumes that all my SQL statements are within the demo database. So I will put the notebook and the data I'm going to be using out on GitHub, and I'll put a link in the description so you can go get it for yourself. But I want to show you the file I'm going to be using here. And I have a bunch of files loaded because I play around a lot in Databricks. But the one I'll be using here is called dimgeography.csv because it's pretty small, not a lot of columns, and I want to demonstrate that. Now, this file is sitting out in storage, but I do not have a table definition for it. It's just a CSV file. And by the way, you can use FS as file system command, and this is a way that I can do like a directory listing. If you want information, I'm going to be using dbutils, which lets us do a lot of similar types of things as file system commands. So to use it, I'm going to set the language to Python, and then I can use dbutils, because what I want to do is use the file system header or head function just to display the top of my file. Why I wanted to do that is just to demonstrate to you that in this file, the first row has the column names to the data. So you can see here like the key, the city, state, province code, yada, yada, yada. And then the data follows. I'm going to be using that to create my table just to make it easier for me. Now let's see if I have this table. I know I have dim geography as a file, right? But do I have it as a table? SQL on Spark is case insensitive, so it doesn't really matter how I capitalize. You can see here, does not exist, right? It says, this is not found. And that's good. I wanted to prove that it really doesn't exist yet. So here I'm just going to use all lowercase, even though I used a mixed case earlier, but I'm going to say drop table gym geography if it exists. And then I'm going to create the table. And I'm saying using CSV. So this tells it what format. And then I'm pointing to the file. I say header is true, so I save myself the work of specifying what all the column names are. I can let it use the first row in the file to get the column names. And I don't really want to have to tell it what all of the different column types are, so I can say in first schema, that will say, oh, I see that this holds a string, this is an integer, and on and on. Now this method is okay for small data sets, but if it was really large, you don't want to do that. But I'm just trying to demonstrate more the Hive Metastore. But I'm going to create my table. And I want to point out something important here. This is called schema on read. What does that mean, Brian? It means the file already exists, but I want to be able to read it with SQL. So I need to create the schema and then I can read it. And now, remember this failed before, and now it lets me query the data. Well, where is the Hive catalog coming in? I don't see any Hive stuff. Well, let's take a look. If we use the describe commands, there's several variations, but describe is used to take a look at the properties of objects in the Hive Metastore. And in this case, we're going to look at the table definition we just created. And you can see when I said describe table extended, gym geography, you can see all the data types, the column names. When you say extended, this extra word here gives you information too, like it's Spark catalog, it's in the demo database, and it also shows you this little thing here, really important, external. So what does external mean? Good question. External means that this file exists independent of the Hive Metastore. And that means Hive is not managing the table. The alternative to the word external is managed. Now I'm going to show you more on this later, but the idea external means if I said drop table gym geography, it won't go back and delete the CSV file that's sitting out on storage. I'm just using DBFS, the Databricks file system, but really it doesn't matter. That is pointing to blob storage under the cover, so it doesn't really matter. It would work the same if it was ADLS or anything else you're using. So the point is external means that I can drop the table and that will only drop what's sitting in the Hive Metastore, but will not get rid of the physical files. So we can see that here. And we can see that it's a CSV file. It even shows us the full path to where it is. Now I can also do something kind of interesting. I want to create another table, geography underscore delta, right? That's going to be a delta table. And I'm going to say select asterisks from dim geography limit 3. Okay, so that created the table. The default format for tables when you do something like this is delta. So it's a delta table. And in this case, I'm just basically making a clone, except I'm only going to take 3 rows. I could do any query I want there, though. Let's do show tables. And by the way, show tables also uses the Hive Metastore to tell me what tables I have in a given database. And since I'm sitting in the demo database, show tables is going to show me the demo tables. So I've got my 2 tables. So a couple of takeaways here. When I was doing this, it automatically cataloged my new table. Now it's interesting too, because the data storage itself didn't exist in this case, right? I'm selecting from a table and I'm saying save it. Where is it? Where's the actual data? Good question. Let's take a look. Now just while I'm doing this describe, I also want to demonstrate that if I didn't use the use database command to set my context, I can always use the database name dot prefix to point to a specific database I want to get information about or use, etc. So in this case, it doesn't matter I'm sitting in demo, but if I was in a different database and I said, oh, get something, describe a table or query something in the demo database, that would do it just by prefixing it the way I have here. So you can see it's got the description. That's all stuff. It's got all the column types just like before. And notice it created a file. I didn't have this file when I started. It created it for me and it puts it under the Hive warehouse demo DB geography. Interesting. And as I mentioned, you can see it did in fact default to Delta. But here's something interesting. It says managed. That means if I were to say drop that table, SQL command, drop table, and gave it this table name right here, it would delete everything, right? It would get rid of all of this data. Imagine if you had spent years putting together data and you just wiped it out. You can also, of course, create views. So in this case, I'm going to create a view, create a replace my geo view, and I'm querying some data. I'm doing an aggregation count, right? Against dim geography group by city. So my geo view, that's another type of catalog entry. But this time it's not going to store physical data. It's just going to store the query itself. I can treat this view, which is really just going to run this query in the background, as if it were a table to query it. And just a quick demo here and see, yep, I was able to query it. And if I describe my geo view, you can see it tells you what, it's only got 2 different columns. They're not physically storing it, as I mentioned. It tells you the name. It tells you it is in fact a view. And you can see here it actually has the query for it. So let's go a step further. We're going to use Python to query using Spark SQL because it's really easy to get data out, but I want to demonstrate saving delta tables and how it works with the Hive Metastore. So I'm just going to say Spark SQL, and when you pass a SQL statement through to the Spark SQL function, you're supposed to wrap it in a doc string, which means triple quotes, your query, triple quote. That way you can run multiple lines, and even if it's a single line, that is the standard. So I'm going to be very standardized today. I'm going to run that. And you can see now I got a data frame back. You can see it's a PySpark data frame, not a pandas data frame, but an actual Spark data frame, and it gives the whole metadata. Now in Python, again, I have to, because this is a SQL notebook, I have to say this is a Python cell. I want to take that data frame I created. I'm going to say write it. If it's there, overwrite it. The format is delta. And then I'm going to say save, and I give it the path. File store tables, geodata file. I want to save it to geodata file in that path. So here's the question. Can I query geodata file as a table? I mean, I saved it, right? I'm saving it as delta. Does the mere fact that it was saved in delta file format mean that it is a table available through Hive? Let's check. If it is, this should work. It didn't work. Why not, Brian? Good question. Because we said save. If I wanted it to catalog it at the same time as saving it, I would actually say save as tables. Save, uppercase A, S, and then uppercase again, table, but save as table. The save method just saves the file. Interestingly, although it failed when I tried to just rely on the Hive Metastore, which is what happens whenever I type in a SQL statement without any pointer to where the data is, didn't work. But because delta files do include their own schema definitions, in other words, inside a delta file, it has the column names, types, all that's built into it, which means I can use SQL. I don't need Hive. I just have to select asterisk. I have to tell it it's delta, then dot, and then I give it the full path to where the file is. Now, bear in mind, these are like backtick marks. They're not quotes. They're not single quotes or anything. They're backticks, which on my keyboard is just below the left escape key. So just be aware of that. But if I do this, it works. I can query it this way. Sort of a takeaway here. I want to back up for a minute. Delta tables are rather interesting. They include their own metadata, but they don't automatically get cataloged into Hive. Even if they're not cataloged in Hive, I can still query them with SQL as long as I tell Databricks where the file is stored. So a little point I want to emphasize here about saving delta files rather than tables. In this day and age, if you're working with Databricks and you're saving data and doing maintenance, you really should be using delta tables. Unless there's some reason you're not, you should be using delta. I said delta tables, but what I really want to say is start by saving the data to delta files and then cataloging them to Hive. Why do I want to do that? Because it gets back to this managed versus external file type thing. And I'm going to demonstrate that in a minute. But if I use the save rather than save as table, it does not get cataloged to Hive. And I have the option later of cataloging it. The most important thing is the drop command will not delete the underlying data. And this is really a strange thing in most of the Databricks documentation because they almost all show it as save as table, save as table. And I think that was kind of in the beginning because like, hey, we want everybody to use delta. The problem is you have this risk of somebody saying drop table, and it might be 3 years of sales history that's out on Azure Data Lake Storage Gen 2. What are you going to do? Now you have to find a way to recover it. It physically will delete that. So usually you're not going to want to do that. You probably want to save it in some other way, and then catalog it. And as I showed, you can save it to a delta file, but not catalog it. But now we want to catalog it. It's out there. We got it. So just in case I'm rerunning this notebook, I'll do a drop of the table if it exists. But we know it doesn't. We just tried to use it. Create table, geo delta file using delta format options. And then I just give it the path. That's all it takes. As I mentioned, it can pull the metadata out of the file, but it will also add the path to the Hive storage entry. So let's check it out. And because I did that, I can now just query it. But most importantly, if I look at the properties, it shows as external. So that means, again, dropping will not delete the data. That may seem like not an important thing, but if you do it, I think you'll realize it is important. I will put a caveat on that. If you're just doing something like you're doing development testing and maybe you're writing to some test logs and things that aren't critical and maybe you don't even intend to use in production, could be a good place where you save as table and then you just work with it that way. And that's okay. But generally in your production data that's meant for reporting and for the business, you're not going to want to do that. So I want to step back for a minute before I finish up this subject and talk about the problem with the Hive catalog. At first glance, it may not seem like there is a problem. It's great. I can do all kinds of cool stuff. But the Hive catalog was created way, way back. I mean, in these day and ages, it's like the Middle Ages. This is back like 10 years ago. That's crazy. And while the Hive catalog provides a lot of functionality, it was created at a time where just getting things running and using big data was such a cool big, deal. But as time has progressed, there were problems that emerged from it. And I'll give you an example of why it became a problem over time. Imagine you have one Databricks workspace in your company, human resources, and another application, accounting has one, and then maybe finance, and then sales, and then marketing, and yada, 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 on and on and on. And imagine too, some companies might actually have each environment, dev, QA, test, production, on and on, for each app. And you could also have many different versions of ones for machine learning and ones for analytics and ones for other things. The point is, you could end up with many, many workspaces. And a Hive catalog is a one-for-one to a workspace. If you have 1,000 workspaces, you have 1,000 Hive catalogs. That's hard to manage, right? And if you want to connect through Power BI or different tools and you want to be able to use different ones, there's no central place to look for things, to find things, to do governance, to give permissions, on and on. You can't really see everything easily. And that is why Unity Catalog came along. One ring to rule them all, or in this case, one catalog to rule them all. Unity Catalog is really meant to be this umbrella catalog that will tie all of your Databricks workspaces together, or more importantly, tie all of your catalogs together. And it gives you a lot of functionality in terms of governance, accessibility, transparency in terms of what your data is, data lineage, and on and on and on. I'm going to talk more about that in another video, but I wanted to just sort of whet your appetite. I'm going to talk about that in another video, but I wanted to whet your appetite as to what Unity Catalog is and how it relates to the Hive Metastore. They're very closely related, and the Hive Metastore is not going away anytime soon that I can see. But if you get into a complex and large installation of using Databricks, it's a good chance that Unity Catalog is something you're going to want to use to make your life easier. So that's it for this time. So please like, share, subscribe. Until next time, I'm pulling for you. We're all in this together. Thank you.